Today in Algebra 2, we're going to look at section 10.1 of Envision Operations with Matrices. Our essential question, how can you use matrices to help solve problems? The essential question for 10.1, how can you interpret matrices and operate with matrices? I can interpret the parts of a matrix, use matrices for addition, subtraction, and scalar multiplication. That's what we should be able to do after today's lesson. So first, let's talk about what is a matrix. So a matrix is a rectangular array of numbers written within brackets. Equal matrices have the same dimensions and corresponding element. We name matrices by the size or the dimensions, which consists of the number of rows times the number of columns. A 2x3 matrix has 2 rows and 3 columns. You can refer to the specific element in a matrix by the row and the column it is in. We will use subscripts for that. A 0 matrix is a matrix with all zeros. So we're going to start out to identify the size or the name of the matrix. So again, this is rows times columns. These are rows, so rows are horizontal, columns are vertical. So here I have 2 rows, 2 columns, so this is a 2x2 matrix. Over here I have 1 row and 3 columns, so it's a 1x3 matrix. This one I have 3 rows and 2 columns, so it's a 3x2. And here I have 3 rows and 1 column, so it's a 3x1 matrix. Now we're going to identify what element is being referred to with the notation from matrix A. This is column 1, column 2, column 3, row 1, row 2, row 3. So here it says A23, so this is row 2, column 3. What number is in row 2, column 3? So row 2, column 3, the number 22. Next one, A31. So it wants to know what element is in the 3rd row, 1st column, -15. The next one, A11. So what element is in row 1, column 1? That's 2. So now we want to talk about scalar multiplication. So scalar multiplication is the multiplication of each element in a matrix by a single real number. That single real number is called a scalar. So it says perform the indicated operation. So 3 times this matrix. So I just multiply every element of my matrix by 3. I have a 2x2 matrix, so my answer will also be a 2x2 matrix. So the first row, the first column, 3 times 6 gets me 18. 3 times -2, -6. 3 times 0, 0. 3 times 5, 15. So that would be my answer. To add and subtract matrices, you add and subtract the corresponding elements. You can only add or subtract matrices that are the same size. So perform the indicated operation. I have a 2x3 matrix, so my answer will be a 2x3 matrix. So 14 plus 18, because they sit in corresponding spots, 32. 11 plus 17 gets me 28 for row 1, column 2. 28 plus 25 gets me 53. Now we're going to go to the second row. So 10 plus 16 gets me 26. 15 plus 9 gets me 24. And 35 plus 45 gets me 80. All right, on the back, same matrices that we had on the front, only now we're going to subtract them. So again, I'm going to have a 2x3 as an answer. So 14 minus 18 gets me -4. 11 minus 17 gets me -6. 28 minus 25 gets me 3. Now we're going to go second row. 10 minus 16, -6. 15 minus 9, +6. 35 minus 45, -10. So there's our answer. So this next set, these are the matrices they give me. So M is a 2x2. N is a 2x2. P is a 1x3. Q is a 3x1. So number 3, find m plus n. So add m plus n. So negative 3 plus 6 gets me 3. 5 plus 5, 10. 2 plus negative 8, negative 6. 0 plus a half, 1/2. There's our answer. Number 4, find m minus q. M is a 2 by 2, Q is a 3 by 1. So this is not possible because they are not the same dimension. They're not the same dimension. We cannot add them or subtract them. Number 5, N minus M. These are the same dimensions, so we can do this. So n minus m, 6 minus negative 3 turns to 9. 5 minus 5, 0. Next row, negative 8 minus 2, negative 10. 1/2 minus 0, 1/2. Number 6, find q plus p. Again, not possible because they are not the same dimension. Number 7, 5p. So we're going to multiply matrix P, everything in matrix P, by 5. So 5 times 6 times 5 times negative 10. I started out with a 1 by 3 matrix. My answer will be a 1 by 3 matrix. So 5 times 6 gets me a 30. 5 times 5, 25. 5 times negative 10, negative 50. Number 8, 6 times Q. So 6 times matrix Q. 7, 12, and 1/3. So my matrix is a 3 by 1. My answer will be a 3 by 1. 6 times 7, 42. 6 times 12, 72. 6 times 1/3, 2. There's our answer. Okay, next page. Find the value of the variables. You see here that these are equal matrices, because I have one matrix on this side, a 2 by 2, and then I have an equal sign and another 2 by 2. So that means my corresponding elements are equal to each other. So I see 12 and 12. So 0 equals y, 2x equals 14. So then solve that for x, I get x is equal to 7. So x equals 7, y equals 0. Another definition. The additive inverse of a matrix is the scalar multiple of -1 times the matrix. So it says find the additive inverse of the following. So basically I want to multiply -1 by my matrix. So -2 times -1 gets me 2. 7 times -1, -7. 12 times -1, -12. Second row, 0 times -1, 0. -22 times -1, 22. 15 times -1, -15. So this matrix is the additive inverse. Number 2, we're going to do the same thing, multiply it by -1. -81 times -1, 81. -1/4 times -1, sorry, that's a positive 1/4. So there's our additive inverse. And it tells us that we can use matrices to organize information. We want to create a matrix to represent the sizes of shirts and sweaters. If you have 5 small shirts, 3 medium shirts, 2 small sweaters, 1 medium sweater, and 4 large sweaters. So I have shirts and sweaters. So shirts and sweaters are going to be my rows. My sizes, I have small, medium, and large. Those are going to be my columns. So shirts, I have 5 small shirts, so that's for my 5 shirts. 3 medium shirts, so 3. It doesn't say I have any large shirts, so that's a 0. I have 2 small sweaters, 1 medium sweater, 4 large sweaters. So that matrix represents that information that they gave to us. So now we are going to talk about how we use matrices to represent a translation. We have a segment with endpoints m at 8, -7, and n as at 1, 2. Okay? So remember that these are x's and y's. So I'm going to have my rows, x and y, my columns M and N. So M, the ordered pair is 8, -7. N, the ordered pair is 1, 2. So now part 2, it says, use matrices to represent a translation of MN to RS by 6 units left. If I'm going 6 units left, I'm subtracting 6. So X minus 6. 3 units down, so I'm subtracting 3 from my Y. And this is going to give me R and S. So I take 8 minus 6, and I get 2. If I take 1 minus 6, I get -5. -7 minus 3 gives me a -10. 2 minus 3, -1. So my endpoints of R and S, so R is the point 2, -10. S is the point -5, -1. So that does it for day 1 of matrices. That's how we add, subtract matrices, use scalar multiplication, and use equal matrices and the additive inverse of matrices. Tomorrow we will look at multiplying matrices together.